Okay, we are starting a new topic on statistics for year 10. As the Ignite group, your assessment for this won't be the test that everyone else gets. You're going to be doing like an in-class over the course of a week. Sort of like an in-class DI. It's similar to the quadratics thing that you did. So you're going to use spreadsheets and statistics to rank how well different countries did fighting the COVID pandemic using statistics knowledge, okay? So actually like making it relevant and sort of current for you rather than just finding the mean, median, and mode. You're going to find the mean, median, and mode and graphs to actually tell a story, okay? So we have to start off with the idea of discrete numerical data. It's a kind of data that results from counting a particular variable, e.g. the number of siblings someone has. So based on that description of what a discrete numerical data is, do you reckon your height would be considered discrete numerical? No. I don't count your height, I measure it, okay? So discrete numerical variables are the result of counting something. Why is that important? Because you can only count whole number stuff. Because it's counted, the data can only take specific integer or whole number values. So like with my notes on the board, it's only the blue stuff that's vital, okay? In higher level statistics, like we are starting now, certain data types must only be displayed in certain types of graphs. You can't just pick and choose. And in primary school, you probably did pie charts for everything. Pie charts are pretty much useless at the higher level, okay? But first, all data should be organized into a table. You'll be given that expectation in science as well. So the first kind of table you should be aware of is known as a tally frequency table. I'm hoping that that's revision for you, but if it's not, hey, I'm giving it to you from scratch now. So what is a tally frequency table? It tells you the possible data values and how often, or the frequency, those data values were counted. The tally column isn't required, but you'll see when we do an example now why it's useful to have a tally. Because it's helpful for tracking your counting before I actually find the frequency. So let's gather data now. How many siblings do you have?
One.
You have one sibling, so I put a tally next to one.
One.
I'm not going to say names, I'm just going to point, yeah? 4. So I'm going to put, has been one occurrence of 4.
1. 3.
One occurrence of 3.
2.
One occurrence of 2.
1.
What do I do after I've got 4 dashes?
Across.
Go across, so that's what you're aware of what a tally is.
4.
Another occurrence of 4.
1. Add 4. 2. 2.
Is it evident why we need the tally? Is it going to be easy for me to keep track of how many ones I'm up to? I'm just constantly saying 7 in my head and then she says 1 and then I get confused and I've lost the count. That's what the tally's for, yeah?
3. 2. 1. 1. 4. 4.
Okay. Now it's clear why the tally is useful, because now what was the frequency of the data value of 0?
0.
Frequency of one sibling?
12.
Frequency of 2? 2. 6. See? Evidence why you should have a tally. If you don't feel like you need it, that's fine. Just don't stuff up the frequency later. So obviously you can see the data column tells you the possible values for the data. The tally column is an easy place to help count the occurrence of data values. And I didn't finish writing that. The frequency is the tally as a number. All right, I'll give you a moment to get that stuff in blue down if you need it. So I'm teaching now is highly applicable to general maths next year if you're doing it, or essential. You might deal with this in methods. So my expectation is always that you put your data into a table first, unless it's provided for you, okay? What I'll do, I do notice that people are still writing. I'll scroll back up to this afterwards, once I finish the video. So graphs are just a visual representation of the data in a table. Discrete numerical variables should only be displayed on specific graph types. So those two graph types are here. A column graph, otherwise known as a bar graph. So what you'll notice about a column graph, the data values are along the x-axis. So 0, 1, 2, 3, 4, 5 along the bottom. That's the number of siblings. And then the frequency goes along the y-axis. It is key that the columns are separated. Right now, you'll probably do something that looks like a column graph that has no gaps between the columns. That is a completely different kind of graph. That's called a histogram. And that represents a completely different type of data, which you'll encounter next lesson on statistics. So a column graph must have separated columns. And please note that a bar graph is literally the same as a column graph, but it's horizontal. So I'm not going to bother drawing that. Just turn this on its side if you wanted to do a bar chart. So can someone remember how many zeros there were? How many people had 0 siblings? 0. How many ones were there? 12. Jeez, I don't have enough. I didn't make it tall enough. How will I represent that it was cut off? I'll do a wiggly line. And then I'll say that it reached 12. Can you just chalk that down? I didn't know what siblings you had, so I didn't have the graph prepared for that. How many people had 2? 5. So the bar's going to go up to 5. Notice the gaps between them. 3 was 2. And 4 was 6. So a very unusual shape to our particular class's number of siblings. Okay. So once again, for the video's sake, apologies for that. That's not how you should draw it, but I didn't know there would be so many people with just one. Okay. A couple of moments to get down to here. The column graph. You can colour those in if you want, etc. As long as it's obvious, as long as there's gaps, you'll be fine. Next, dot plot is the other kind of graph you can use for discrete numerical data. This is a little simpler. You simply have a single x-axis. The data values go along the x-axis. So it's siblings again. But the dots are evenly spaced vertically, represent the frequency. So was there anyone that had 0 siblings? No. There were 12 people that had 1 sibling. So the way that I'll draw that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Still didn't have enough space. 11, 12. How many was it for 2? 5. 1, 2, 3, 4, 5. 3 was 2. 4 was 6. Can someone explain to me why the vertical even spacing is important for this particular graph? Why would it be important that I space them evenly? Yeah?
For comparison.
For comparison. If I didn't space them evenly, do you agree that I could have spaced out the 4, 1, 2, 3, 4, 5, 6, giving you the impression that there were just as many people that had 4 siblings as 1? They must be evenly spaced. It's up to you to decide that spacing. You just have to be consistent about it. Okay? Basically, a dot plot's a column graph. It's just dotted. Right? Now, a couple of moments for this. Give you time after to get that back. So just remember, I'll give you time to go back on it after. It's just for the purpose of the video. I'm not aware if you've talked about shapes of distributions, but we'll deal with that now. Numerical data is special because numbers have an inherent order. Can someone tell me what inherent means?
It's just
Good, pretty good.
natural.
Yeah, you could think of inherent as natural. So you could, well, I don't know. Asians inherently have black hair. Okay? Numbers naturally have an order to it. Do you agree that 0 is what in comparison to 1? Is it less than 1 or is it greater than 1? 0 is less than. Which is less than. Because they're numbers, do you get a choice in that? No. And because they're numbers, that means that if I have a shape to the graph, it means something. You may have encountered previously, have you heard of the idea of categorical data? Is that a bit fuzzy? Categorical data is data that is named. For example, hair color. Because is your hair color a number? No, it's either blonde, brown, black. Is there an order to that? There's no order to that. So if I drew hair color on the bottom, it's literally up to me what order it goes in. And therefore, would the shape have any meaning whatsoever?
No.
Because I could just order it differently and the shape would be completely different. But have I established here that you have no choice in the order of numbers? It goes from low to high. So when the data is numerical, the shapes mean something. So these are the 3 distribution shapes that you need to be aware of. It's either symmetrical, which is logical if it's the same on both sides. You have most of the data. Where is most of the data lying in the symmetrical distribution? On the outsides or in the middle?
Middle.
In the middle, in the middle. Usually the average. Because do you agree? Would there be a lot of people that are average in height? As you get taller and taller, what happens to the number?
Decreases.
Yes? As you get shorter and shorter, what would happen to the number of people that are super short?
Decreases.
Decreases. Good. This is found all over the place. And you can see the frequency drops away the same on both sides. This is tricky. People get stuck around this because the name of it is the opposite of what you would think. Where is most of the data in the positively skewed graph? Is it on the low end of the numbers or the high end? Low. It's the opposite of what you would think. Most data on the low end when it's positively skewed. And obviously the opposite would be the case for negatively skewed. Most data on the high end. Unfortunately, our class data for siblings, it was like bimodal. It had a spike in the 1, then it went down, and then it went up again. So you had a bunch of families. 2 is enough. And they calmed down, and then they got busy again later. That's, hey, That's how babies are born, huh? All right, a couple of moments for those three ideas. Can I just check, have you heard of the term outliers before?
Yep.
Okay. There's a mathematical definition for that. So I just want to practice identifying outliers. The last thing we need to consider is the idea of outliers. An outlier is a data value that lies outside, either much larger or smaller than the general trend of the data. Outliers can often be identified because they stick out far away from the main shape. In our dot plot below, does there appear to be outliers?
Yeah, the 0.
Down to the 0, we had
And then-
2 instances.
And arguably 9 and 10.
Yep, yeah, I like that you would say arguably. You need more information to determine whether they really are outliers, but by this definition about them lying outside, do you agree that this is the general trend of the data? We've got a spike in the middle, probably symmetrical, maybe actually slightly negatively skewed, because can you see there's a big chunk of the data slightly on the high end?
Yep.
We don't know enough to definitively say that these are outliers, right? But the thing that determines the real decision about whether something's an outlier in maths and science, outliers can only be ignored or discarded from the data if they're confirmed to be the result of human error. If you can't track down whether it was a mistake, it was a legitimate piece of data, you cannot ignore it. That's a rule for maths and science. If I'm measuring the weights of apples on a tree, and there was a real big boy there, I can't ignore that. That was on the tree, right? But if I was typing in the weights on the computer, and instead of pressing 9, I accidentally pressed 0, and then you had like some apple that didn't weigh anything, is that a mistake?
Yes.
Then I can ignore that. But if it actually exists, you can't just ignore the giant number. It was a legitimate piece of data. Okay? So I'll stop the recording there.